Assalamualaikum and hi. My name is Moiris bin Abdullah. Today, I want to share about the usage of ultraviolet visible spectroscopy in the pharmaceutical industry. Before we start, I want to explain a little bit about this pharmaceutical industry. Pharmaceutical industry is the one who discovery, development and manufacture of drugs and medication by public or private organization. The modern era of the pharmaceutical industry is the isolation and purification of compounds and chemical synthesis. So, let me continue to the main topic, which is the usage of ultraviolet visible spectroscopy in the pharmaceutical industry. Okay, basically, ultraviolet visible spectroscopy instrument are used to identify, characterize and quantify an extraordinary wide range of molecular compounds. It can be used for non-destructive measurements such as determine the sugar, lipid, protein content of foodstuff and for identifying medicine. When a material is irradiated with an electromagnetic wave, phenomena such as transmission, absorption and reflection can occur. Absorption occurs when the energy of incoming light is equal to the energy difference between a molecule's ground state and excited state. The excitation of an electron from the ground state to excited state is described as an electronic transition. The benefits of this ultraviolet visible spectroscopy, or known as spectrophotometry, is a quantitative technique that can be used to measure how much a chemical substance absorbs light. This is done by measuring the intensity of light that passes through a sample with respect to the intensity of light through a reference or blank sample. The property is influenced by the sample composition, potentially providing information on what is the sample and at what concentration. This technique can be used for multiple sample types including liquid, solid, thin films and glass. Since this spectroscopy technique relies on the use of light, let's first consider the properties of light. Light has a certain amount of energy which is inversely proportional to its wavelength. Thus, shorter wavelength of light carry more energy and longer wavelength carry less energy. A specific amount of energy is needed to promote electron in a substance to a higher energy state, which we can detect as absorption. Electron in different bonding environment in a substance require a different specific amount of energy to promote the electron to a higher energy state. This is why the absorption of light occurs for different wavelengths in different substances. Okay, let's move towards to the application of ultraviolet visible spectroscopy in pharmaceutical industry. Ultraviolet visible spectroscopy usually used in dissolution testing of tablets and products. Dissolution is a characterization test commonly used by the pharmaceutical industry to guide formulation, design and control product quality. Pharmaceutical produce many drugs are either in the form of raw material or in the form of formulation. Therefore, they can be analyzed by making a suitable solution of drug in solvent and measuring the absorbance at specific wavelength. The ultraviolet spectroscopy are used widely in pharmaceutical industry because this analytical technique able to measure the visible and ultraviolet region of light spectrum that can provide valuable information about the level of active ingredient present in this pharmaceutical compound. Also, this analytical technique is good for detection impurities of pharmaceutical compound. This shows that by measuring the absorption of UV radiation of light, spectroscopy analysis can quantify this level at highly accurate and precision. Therefore, this analytical technique is help to analysis of chromophore in pharmaceutical compounds. There are many products that are contain chromophore that have been analyzed by UV visible spectroscopy. For example, medicine like antibiotic, hormones and vitamin. For the data, the relationship between the energy difference and wavelength is described by the Planck equation. Planck's equation then demonstrates that the less energy needed to excite the electron, the longer the wavelength of the absorption band. The absorption bands are indicative of the molecular structure of the sample and will shift in wavelength and intensity depending on the molecular interaction and environmental condition. These bands are typically broad and featureless due to the numerous molecular vibrational level associated the electronic energy level. This is the example of absorption spectrum. The peak around 280 nanometer require less energy to promote electron into the excited state than the peak around 215 nanometer. I think that's all for me. Thank you and bye-bye.